Hello, how's it going? Um, I'm fine. I mean, it's Monday morning for sure, you know. Yeah, I'll just let it be there. Did y'all have a nice weekend? Cool. Very cool. Well, hold on one second. Okay, so what I want to do. Whoa, okay. Just a couple very quick announcements. Let me think if I can remember what my announcements are. Yes. So, you have less than 2 online homework Wednesday by midnight. There's the class activity number 2. I do want to add, just so that there's no ambiguities, that these class activities are required for everybody, whether you're attending the class remotely or whether you're coming physically in person. That's why I post them on the Moodle page. And that's why you can hand them in to me either physically or via email. I don't have you hand them in to me on Moodle, just because that sort of sharing thing can sometimes cause bumps for people. If you need a copy of the class activity 2, I have them here. If you handed in a physical copy of class activity 1 or class activity 2, because some people have already handed it in. When you give me a physical piece of paper, I have them to give back to you. But those of you who email me their class activities, I don't print them out on top of it. So, but I do post the solution. So the other comment that I want to make is that I have announced that ideally you would get it into me in person, either by class tomorrow or email by the end of class on Wednesday. I will say that as I let you know, we're Zooming class on Wednesday. Okay, so you're welcome to come here, but you're going to Zoom because I'm going to be over in Billings. But I will definitely sneak out and teach all that class. If you need to wait till Friday to get it to me, I'm okay with that. The reason why I don't like extending due dates too much, though, is because we're not slowing down in class. And again, it's not like I try to go fast, but you know, I want you to keep up with the work to the best of your ability. But I did want to put it out there that I'm happy to accept them through Friday. The sooner you get it to me, the sooner you have it off of your shoulders. Yeah. How about when you leave class or at the end of class? Yeah, totally. I mean, I'll take them anytime. I just want to be mindful that, you know, everybody's keeping up and that you also have enough time to get your questions answered in the way. Okay. So I wanted to continue the conversation on lesson 3 that we were talking about with the combinations that we did barely got started on Friday in class. But before I do that, I would like to ask, does anybody have any questions over any of the ideas that I've talked about, any of your online homework, or anything off of this class activity? Yes.
So the lab activity is 2C. It says how many of these arrangements do you have the original word here? I didn't understand.
Okay, I'm happy to go through that. So if you all just want to let me know all of your questions, what I'll do is I'll just write them down and then I'll just go through them in numerical order. So 2C is one of them. Anything else? Yeah. 2B, okay. Okay, cool. So number 2. Anything on number 3?
Um, 3F.
3F, okay. So 3E and F. Cool. Thank you for asking questions. Okay. So let me grab a copy of it. All right. So here we have the letters of the word caribou. Notice there's no repeats, so we don't have to worry about distinguishable permutations. Okay, right? Each letter appears only once here, so we don't have that to worry about. Here, let me zoom in here. Okay, so essentially we have the letters of these words scrambled and they're arranged in random order. Notice we have the word arranged, which means that order matters here. Okay, so we want to know in number 2, part A, how many different arrangements are there? Okay, well, first off, how many letters are in the word caribou? 7. 1, 2, 3, 4, 5, 6, 7. Notice I'm using my multiplication principle because if I have a C here and an A here, that's very different than an A here and a C here. Okay, so how many possible letters could we put first? 7, but we're going to put 1. So how many are left to go here? 6, then 5, 4, 3, 2, 1. Yay! 5,040. Yep, if you wrote 7 factorial, I'm cool with that. Question. And if as I'm going through these, you don't understand something, stop me. Okay, for real. Okay, so now we want to know how many of these arrangements begin with a vowel. Notice I tell you what the vowels are. I don't assume that everybody's a native English speaker. And I think it's just important so that there's no ambiguities there. But please note which are in this particular word. So we're still wanting to arrange all 7 of those letters, but the first letter needs to be a vowel. Okay, so how many vowels are in this word? Well, we have A, I, O, and U. So how many choices do we have for the first letter? 4 choices. Okay, but do you agree we're going to put one of them there? And then we can't use that one anymore. Okay, does that make sense? Awesome. I love your facial expressions. They're awesome. Okay, so now that we've put one letter down here, how many choices do we have for this next letter? 6, then 5, 4, 3, 2, 1, and we can multiply across, and you're going to see that we have 2,880 choices. Does that make sense? Awesome. All right. Next, how many of these arrangements read as the original word? Now, you can take a long way to solve it or a short way to solve it, but 1, 2, 3, 4, 5, 6, 7. Okay, if we want it to read as the original word, don't we need to have a C here? We need to have an A here. We need to have the R, I, B, O, and then U, right? If we wanted to read as the original word, we don't really have a lot of options, okay? And how many ways can we pick a C? One. How about an A? One. If you just wrote one at the bottom and didn't have all of this, that's fine, because there's really only one way to spell caribou. Isn't that rather anticlimactic? In only the best of ways. All right. So the next page. So we want to do 5-digit zip codes. Most common mistake that people make is they think that you only have 5 digits to choose from. There's 10 digits. We're choosing 5 of them. Okay, so be careful with that over these. So we wanted to do parts E and F. So we have 5 choices that we have to make. No 0 here. Must be a 9. And no repetition. Okay. When you are doing these on your own, I recommend that you start out by writing the restrictions underneath. Okay. These aren't going to differ that much, one from each other. The thought process is the same. Okay. So where do we start? Okay, we start in the most restrictive place first, don't we? What's more restrictive, saying no 0 and no repetition, or that it must be a 9? Must be a 9. Okay, you got to start there. Okay, in how many ways can you pick a 9? 1, you pick it. You with me there? Awesome. Now, the next most restrictive place is no 0, but what else can we not have? We can't have a 9 either, right? Because there's this no repetition business. So if we have 10 digits to begin with, and we can't use a 9 and we can't use a 0, how many choices do we have for the first letter? Or first number, sorry, 8. All right, questions this far? From here on out, we just have the issue that we cannot repeat anything, okay? That's the only parameter for us here. So how many letters have we, or excuse me, I can't tell the difference between a letter and a number today. How many digits have we already used? We've already used 2 of them. Okay, so I can't use 2 digits. So how many choices do I have for here? 8. And now I've used 3, so 7 and then 6. Okay, remember this is an 8 because we can't use the 9 and we can't have a 0. This is an 8 because we can't have repetition and we've already used 2 digits. And then this is a 7 because we've already used 3 and then 6. Okay, so now we have that the first digit is a 2 or a 3. It can't end in a 0 and no repetition is allowed. Again, whenever you are doing these, like have it at the top of your papers, start with the most restricted place, okay? What is the most restricted place here? 2 or 3. We're not being told as definitively what must happen, but we're still kind of being brought into a corner and saying, hey, you can only use a 2 or a 3 here. All right, well, let's start there. How many choices do we have for this first letter or number? 2. Right? We can choose a 2 or a 3. Do you agree that we're going to pick one? One of them. Yes. Okay. What's my next most restrictive place? No 0. Okay. Is that my only restriction for this last digit? No, no repetition. So I can't use a 0, but I also can't use whatever I used in my first digit. So how many choices do we have for this last one? 8. Good job. Right? We can't use a 0 and we can't use a 2, or we can't use a 0 and we can't use a 3, depending upon what we picked there. All right. Got 3 more to go. I claim that the reasoning here for the last 3 places is the same as what we have up here. For these 3 places, my restriction is no repetition. How many digits have we selected? 2. So again, if we start out with 10 digits and we've selected 2, how many choices do we have for here? 8. Now we've selected 3 digits, so 7 and then 6. And you multiply across. And I do want you to multiply across. I figure you can handle that. Again, before you go and work on these things, I really, really encourage you to review the examples that we've done in class. The thought process you will see once you start getting used to these is very much the same. They just have their own little peculiarities, for lack of better term. Does this help?
Yes.
Awesome. Are there any other questions? Did anyone do anything super fun over the weekend? Awesome. Where'd you go?
I went up by Melrose.
Uh-huh. Cool. Yeah, that's awesome. Anyone else? I went on some awesome hikes. And then last night I had a very melancholy evening. I took my kids out for dinner because my son's about to split for Japan for a year. And unless I go see him, I won't see him for 11 months. It's a long time not to see your munchkins, totally. And I have the coolest kids, so anyway. Alas. Can't believe he's going to. He's going to go study abroad. Yeah, he studies Japanese. So it makes sense what he's doing. All right. No, it's one of those things, you know, like you want your kids to go do everything and have the best time, and you're still here. All right. Well, let's pick up where we left off. Sound like a plan? Cool. So we were talking about, we keep being asked the question, in how many ways can something happen? Okay, once you're asked in how many ways, you know you're counting. Okay, and at this point, we really only learned to count in one way, and that is when order matters. Okay, order matters when you're spelling a word, order matters when you're entering a telephone number, a zip code, a PIN code, or really whenever you see the word arrangement. Okay. What we just barely got into last time was what happens if we want to know in how many ways we can do something, but the order doesn't matter. Okay. Now, when does order not matter? Order doesn't matter if, for example, I have a collection of objects here. Let's just say that they're radish seeds. And, you know, maybe I want to do some sort of experiment on some of the seeds. So if I have a bunch of radish seeds and I just pick a sample of them, I claim the order in which I put the seed into my sample doesn't matter. Okay, they're still in my sample and I get to experiment on them. Okay. Another really common example of when order doesn't matter is when you have a committee. If you're picking a committee of people where every position in that committee is the same, the order in which the people are selected does not matter. Okay, they're still stuck on that committee. We saw at the end of class on Friday that there is a situation when selecting a committee when order actually does matter. But that's when the first person you pick has a very specific and definitive role. The second person you pick has a definitive role, et cetera, et cetera. Okay. Now, these things come with practice in terms of being able to determine whether order matters or doesn't. But in general, if you're picking a sample of something or you're picking a committee where each distinct role on that committee doesn't exist, order does not matter. Okay. So this is a place where you want to have a calculator on a test, you know, to compute these. You know, you'll have these little calculators in the meantime. Hopefully, if you checked it out of the library already. In the meantime, you know, of course, you can Google online combination calculator, and they exist. Okay. So the example that we started with or ended with really in class on Friday was we had a club with 20 members and they need to select a committee of 5. And we wanted to know in how many ways can the committee be selected if, in part A, we had no restrictions. Okay, so the first thing you note, and again, I'm telling you this again and again so that you ask yourself these same questions when you're on your own answering, doing homework or what have you. We're asked in how many ways something can be done. So we know we're counting, okay? It's important to note this because when you go and you take a test, there's going to be a lot of different test questions and you need to know how to proceed, okay? So number 1, we know we're counting. Number 2, the next question we ask ourselves is, does order matter? And I claim here, we're just picking a silly committee. The order in which we pick these people does not matter. Okay. So we know that we have a total of 20 people.
And we want to choose 5. I did this at the end of class last time, so it might look duplicative from your note, but okay. We see that this is a combination because the order doesn't matter. We have 20 and we want to choose 5. This is one way we can write it. Another way that I showed you that you can write this is 20, choose 5. Note, don't put a fraction bar because 20 over 5 is 4. That's not it. Okay. Or you can write 20 NCR 5. These all mean the same thing. I'm not going to tell you how to write it. Honestly, this is usually my favorite way of writing it. Students sometimes don't like this because it's so easy to put a fraction bar, and technically if you put a fraction bar, it's wrong. Although I do have grace for the learning curve with this, okay? But regardless, you need to compute this. This, again, you don't need to use that formula that I showed you on the calculator that you can check out of the library. What you do is you first enter your N, which in this case is 20. And if you have one of those fancy TI-83, TI-84 calculators, you're still going to start that way. With this calculator, again, I showed you there's this factorial, then it says NCR, NPR. So you're going to hit it twice. And then 5. So there's 15,504 ways to pick this committee. Those of you with a TI-83, TI-84 calculator, we went through this last time, but then what you would do is you would hit your N, your 20, and then you have a button on here that says math. And then you cruise on over to PERB and then hit the NCR. If you have that sort of calculator, I'm happy to show you one-on-one with that. Okay. All right. So to contrast that no restriction with something where there is a restriction, suppose we have Sue. Suppose Sue is in this club and she must be on the committee. And for simplicity purposes, let's assume there's only one Sue in our club. Now, one of the things you're going to hear me say a lot in this section is before you start writing anything down, translate. Okay, for real. This is huge, and it'll come out especially in our next example. So Sue's got to be on the committee. Poor thing, right? What a bummer. So what do I mean by translate? Well, what does it mean that Sue must be there? Do you agree that we need to select Sue and 4 others? Okay, if you wouldn't have thought to translate it this way, don't sweat it. Okay, this is why I'm going to just be spending the rest of this class and then some doing a ton of examples. Okay. So I also on Friday told you that and or are some very special words. We saw that and is intersection, but what operation did we put that with? Anyone remember? Multiply. And or we saw with union, but what operation goes with or? Add. Okay, those are so important. And you'll see why in a moment. Okay, well, let's talk about how we can do this. We want Sue. In how many ways can we pick Sue? 1, there's only one Sue, that's it. She's stuck. Okay, now we need to pick and for others. And means multiply. How many other people do we have to choose from? Oh, you're so awesome. We have 19 people left to choose from. Why? Because there were 20 in the club, but Sue's already taken care of. And how many people are we picking? 4. If you compute this combination in your calculator, you'll see that you get 3,876 different ways. You with me here? Yes. Because order doesn't matter. Yes, that's a great question. All right. Are you ready? Okay, let's change this up slightly. Oh, awesome. Can you go over how to do this on the TI-84 calculator again? Yeah, what you would do is on the TI-84, what you would do is you would first enter 19. You would press the button that says math. You would arrow over to perb because we're really doing all of this so we can compute probabilities soon enough. And then you go down to number 3, which says NCR. And then you would enter the number 4 and then hit enter. Thanks for asking. All right. So now what we're going to do. Are you ready? We're going to do another committee and then we're going to talk about chocolate because chocolate's more fun. Okay, suppose there's 20 members in some club. And in order to keep this more simplified, suppose we again want to select 5 people for a committee. And let's suppose in this particular club, there are only 2 genders. Okay, and let's suppose for the sake of this example, that there's 9 male and 11 female. All right, I'm honing it down to just 2 genders because we can start introducing more soon enough. But it gets more complicated the more genders you put it, or the more options that there are. Okay, so what I want to know is in how many ways can these 5 people be selected if on this committee we want all men? All right, I'm going to start out by saying translate. Okay, notice if I didn't put any restrictions in, it would still be 22-5. Okay, we got 20 people, we're choosing 5.
But now I'm starting to put people into different pockets, if you will. So in this case, we want all 5 of these people to be men. Do you agree that we can translate that to 5 men and no women? You agree? Cool. Okay, it might seem silly to do that at this point. Just bear with me, okay? All right, we're starting to get pickier here. How many men are there in this club for us to choose from? There's 9. And how many do we want to pick? 5. So we could say there's a total of 9 men and we want to choose 5. What does "and" tell me? Multiply, good. Okay, how many women are in this club? 11, and how many do we want on this committee? 0. Now, as it turns out, you don't have to put anything to choose 0, because in how many ways can you choose no women? 1 way, you don't choose them. Okay, but I am going to put this right now because I'm going to start introducing something that I'm going to call a check mechanism. Okay, do you see how my 9 plus 11 add up to my total of 20 people? And my 5 plus 0 add up to my total number of people being selected? It's a good thing to keep in the back of your head. Okay, I'm planting a seed for when we move forward. Okay, so if you compute this, there's 126 different committees. 9 choose 5. Okay, 11 choose 0 is 1. But if you go in your calculator and you hit this combination 9, 5, you're going to get 126. All right. What if now I want on this committee 3 men and 2 women? Well, we've accounted for all 5 here, correct? Okay, how many total men are there to choose from? 9. And how many do we want to choose? 3. And tells us what operation? Times. How many total women are there? 11. And how many do we want to choose? 2. So now what we would need to do is compute 2 combinations and then multiply those values. Okay, so if we want to do that, we have 9 choose 3, which is 84. And then we can do 11 choose 2, which is 55. And 55 times 84 is 4,620. Questions here? Okay. So now what I want to say is as follows. We're going to come across a bunch of different phrases in here, and it's really important to be able to translate them. Okay, this is where you're thankful that you get a sheet of paper with notes. You're going to learn it just by practice, but it's helpful to know ahead of time that you don't have the pressure to memorize, right? Okay, but sometimes we like talking about at least some number, or at most some number, or no more than
some number, or no less than some number. Whenever you see phrasing in this sort of way, what I want to tell you is prepare for more than one possibility. Like if I tell you that I have at least one cat, there's more than one possibility. I could have one cat, I could have two cats, I could have three cats. For goodness sake, I could have 25 cats. Right? Okay, so once you see this, you need to keep your eye on the idea that there's more than one possibility. So I'm going to tell you the steps that you're going to want to do moving forward with these types of questions. And I recommend you don't just jump and answer them, you go through these steps. The first step is translate in the context of the question. The second step is to account for the entire sample. And then, last but not least, set it up mathematically. If anyone needs a lab activity, right here. Totally. I cannot overemphasize the importance of doing these steps in this order. Okay. So often, yeah, you could just put it right there. Thanks. Sure.
Okay, thank you.
Yeah. So often, people just try to jump into the last step. Take your time and think about it. Okay, please. So let me show you what I mean here. And don't worry, this is not the only example we're going to do. We're going to do a ton of them tomorrow. Okay, so the idea is that you're so bored in here because you totally get it and you see the structure of how to answer these questions, but we need to build to get there. I honestly think sometimes that this class in certain parts is more of a reading class than it is a math class. I think a lot of it is translating. But suppose again, I've got these 20 people and I'm still going to be in this scenario where there's 9 male, 11 females. But now I want to know in how many ways can they be selected if at least 4 women need to be on the committee. Okay, first off, at least. So, as I mentioned on the previous page, prepare for more than one possibility. Okay, now our first step is to translate in the context of the question. So what does at least 4 mean in the context of this question? It means 4 women or 5 women, right? If it's at least 4, it's 4 or more. Why did I stop at 5?
because my committee is maxing out at 5 people. Okay, so that's what I mean when I say translate in the context of the question. Okay.
Well, now let's narrow down to specifics. Okay. Again, the next thing that we have to do is account for the entire sample. So the way I would write that is 4 women or 5 women. Okay. Now I'm not done. There's 5 people on my committee. If there's 4 women on my committee, what do we know about the other person? There's 1 man. These have to add up to 5 because there's 5 people on the committee. Notice the word or just naturally fell off of our tongues. That's a really important thing to keep in mind. What if there's 5 women on my committee? Then the men's scam, they don't have to be on it. You can tell how I feel about committees. All right. Are there questions this far? Notice the first thing I did is I translated in the context of this question, and then I accounted for my entire sample. Each of these have to add up to 5. Are there any questions here? And again, if this seems funky, don't worry, we're going to jump right in tomorrow morning. Okay. How many total women do we have to choose from? 11. How many total men do we have to choose from? 9. Okay, the total number we have is not going to change, but in this particular case, how many women did we want to choose? And how many men did we want to choose? 1. What does OR tell us in terms of mathematical operations? Add. Now let's set up this other portion mathematically. Again, we're still starting with 11 women and 9 men. But now in this case, how many women do we want to select? 5, and how many men? None. Okay, some things I want to point out. Okay, and then we'll get deeper tomorrow. We wanted at least 4 women. Notice that meant in the context of this question 4 or 5, because there's only a total of 5 people on my committee. Then what I did is I accounted for the rest of my sample. They both need to add up to 5. Notice your top numbers are always the total. Do you agree in each of these terms that my top numbers add up to the total of 20? And once I identified how many of each, do you see how that gave us our bottom numbers in each of these? And notice in each of them, they add up to 5. We'll compute this tomorrow and we'll do a bunch more. Okay? But this is where, you know, like talking to yourself is the nicest thing you can do. You can. So please be sure that you talk to yourself as you're working through these. I know that that sounds like, wait a minute, I'm supposed to talk to myself? Yes, because as you talk your way through these exercises, what's going to happen is those ands and ors are going to come out very naturally. All right, see y'all tomorrow. Have an awesome day.